Hello, darkness, my old friend. I've come to talk with you again.
Hello everyone, today is our brand new tutorial about how to find distance from a point to a line. First of all, it is distance between some 2 points. First one lays on our line and second one is given point. Second main idea is that we don't need a distance which is not minimum 1 because there are many points on the line and we can calculate any distance. Let's speak a little bit about properties of distance between 2 points in Rn. Distance between 2 points which is given as a list of coordinates in Rn is equal to such formula. And what about distance between a point to a line? Is there any formula that is true for every dimensions? Let's speak a little bit about simple R2 case, where line, as you can see, is going through origin. And normal vector for this line is AB, and we can denote it as n, which is equal to vector AB. From definition, distance is projection on normal to a line in this case. So we can write down this formula. Now we multiply and get the result, which is equal to absolute value of line with coordinates of point P divided by a squared plus b squared. You may ask, what if line is not going through origin? Let it have such equation, and we will take line which is parallel to it and going through origin to use our previous case. Its equation will be just the same but without this c, and we have to know on which value we need to lower our point P to get the same distance. This value is intersection of point L and our ordinate line, and we will get value minus c divided by b. So our point P1, which has distance to L, to our new line L, the same as P to old L, is x0 and y0 plus c divided by b. Now we use our previous case formula, but with new coordinates, and we will get a general formula for line which is not going through origin. Now let's speak about a little bit harder R3 case. Let we have line going through 2 points A and B with coordinates A1, A2, A3 and B1, B2, B3 respectively. And suppose we want to have a distance from point C to that line, and let's see how coordinates C1, C2, C3. Now, any point from our line can be described as such list of coordinates with some real number t. So distance from any point to given point can be described as d, which is equal to such formula, as it was described earlier. Now we will take this distance in power 2 for easier calculations. Now we get this line is just the square of previous. Now we remember our second main idea, that the distance from a point to a line is the minimum distance between some point on this line and given point. So we need to take derivative from our d square with free variable t. And we will get such equation, which we have to say that is equal to 0 in order to find the minimum one. As you can see, these three things are distance from point B to point A in square. And this is the scalar product of such vectors. And so we can write that t multiplied by distance from B to A in square is equal to a scalar product of such vectors. As a result, we get t. Now we'll use our t to get minimum distance from our formula, and we will get such thing. As you can see, y plus z is minus z. So we can write that our distance is equal to such thing. Now we will a little bit change it, and now we remember the definition of vector product. So we can take that d is just vector product divided by absolute value of AB. So we can change AB on BC because it describes the area of triangle. Means that vector product is the same as this one, And I will speak about a little bit harder case with Rn. It actually is the same as previous case, so we are not going to show you all these things because all calculations are just the same, and we will give just you the final formula which works in Rn.
So let's start with simple example in R2. We have there a line which defined by equation minus 3x minus 4y plus 12. And it also defines the points A and B on axis. So let's measure a distance between point C and line AB by such equation that we use in theory part. We substitute x and y with two coordinates of C and got 12 over 5. Let's check our result. So there we have two triangles, BCH and BAC. They are similar because they have the same angle B, and angle BHC equals angle ACB, and it is 90 degrees. And after that we have that CH over AC equals BC over AB from similarity of triangles. And from that we got such equations where CH equals 12 over 5. So it proves that our result is correct. So let's continue with example in R3. Assume that we have such cube with points C, A, and B, and we want to find a distance between point C and diagonal AB. What we have to do, let's firstly calculate distance between C and AB with formula from theory part. We did the same calculation as in previous example, and we got square root of 2 over square root of 3. Now let's check our result. We have the same triangle, ABC and H, and we just found that triangle BCH and triangle BAC are similar as in previous example. And we did the same equations, the same calculation, and got the same result, square root of 2 over square root of 3. So our results are correct.